I'm a surgeon, and you have to wonder, you hear all these great tools, and AI is kind of circling the operating room, but it's not directly involved in patients very often. In fact, there's really no medical device, AI medical devices that are really available. It's a little bit different. The other part of my practice is flexible endoscopy, and it's a little bit different there. We actually have some AI medical devices that are approved and in daily use. They're fairly basic right now. And I'm going to give you a little bit of a case study of how you bring an AI concept into an actual commercial medical device. And that's in the flexible endoscopy field. So disclosures, and the one that's relevant here is Ai2m, which I was involved in spinning out of the Ai2m where I worked in Strasbourg and remain involved with. So AI and flexible endoscopy is a little bit ahead of surgery for the most part. It's been involved in colon polyp detection. That's kind of the main commercial aspect of it. But there's projects also in inflammatory bowel disease, Barrett's esophagus detection, gastric cancer detection. I'm not going to talk about those that are already established. I'm going to talk about, once again, give you a case study of a specific one there. But it is used every day. Medtronic's GI Genius is in many, many operating rooms throughout the world, and there's already a very robust commercial competition in this with multiple companies now in the polyp detection field. I'm going to talk about a research project that started in 2020 that we did at the Ai2m. It's called APIUS, Augmented Pancreatic Endoscopic Ultrasound, that now is in process of becoming a commercial device. So this is a project, PIs were a clinician, Leo Sosa, an endoscopic ultrasonographer, and Nicolas Padois, who's a computer scientist of high level, runs the CAMA team at our institution. And really the need that was seen that started this research was the fact that endoscopic ultrasound of the pancreas is extremely difficult, very, very complex, and because of that, it's not easy to access, and the quality is uniformly fairly poor. It has a high endoscopic ultrasound essentially attaches an ultrasound probe to the end of a flexible endoscope, and flexible endoscopy is not that easy in and of itself, but when you add 2D ultrasound interpretation onto it, it makes a very high mental workload for performers, and you have to manipulate the scope at the same time you're interpreting images. Just very difficult. Typically, you're trained to do that with a 1 to 2 year postgraduate fellowship in advanced endoscopy, where typically you graduate with 200 cases or so. The problem is it takes greater than 1,000 cases to obtain mastery, really, a high level of competency in this. So most graduates of training courses go out into practice without being fully trained to high levels of competency. And in fact, the general practitioner really doesn't have a volume to ever get to a higher level. So the only way you can really get to a high level in daily practice is if you're at a very high volume practice with mentors. So we thought that was a bad data. This is the primary tool to diagnose pancreatic cancer, and as you all know, pancreatic cancer is uniformly lethal. And the only chance you have of surviving pancreatic cancer diagnosis is very early detection, and this is the primary tool to detect pancreatic cancer. So if you're bad at doing it, you're going to miss lesions that could be cured, and the patient's going to die. So we thought it was a pressing issue. So we hypothesized that the benefits of AI-assisted EUS would be improved precision accuracy, reduced procedure time, deliver better patient outcomes, improve documentation and data analysis, but I think you can package that all together that we wanted to give a tool that gave the practitioner better quality, gave the patient better quality endoscopic ultrasound. So there's other people working on this. There's several papers. I won't go into detail about these. These are typically very limited exploratory studies, single center data sets, kind of very small data sets taken with still frame images, And so when you really dissect it, there's not very much data that has gone into the things that were published. Some of these sound better, that they have 22,000 images, sounds great, but these are still frame. So each image had less than 1 second of analysis, and so this is 15 minutes of data to create a tool, and that's obviously not going to work. Same issue with this paper as well. So my team at IHU includes computer scientists, as I mentioned, under Nicolas Padois' direction, and a group of clinicians. Most of us perform endoscopic ultrasound, so we thought we had a good team to do that. Applied for a grant in 2019, got almost €2 million grant, supplied extra funding through our internal mechanism mostly for translation, and that set the stage for doing this. We think the institution was a good place to do it. It has a big data set. We already had 500 cases pre-recorded of EUS. We had a good annotation tool and team, and big computational power because we have a large computer science team in the institution. So one of the things we quickly found, it's fine to have 500 videos, but they're useless, as all the computer scientists know, without being annotated. And annotation is really the bottleneck for producing a commercial product here, because it has to be high quality, validated, vetted annotation done very, very carefully. I think most people know why annotation is hard and takes a long time, interpatient variation, et cetera, et cetera. The real one, though, is shortage of experts to collect and annotate these cases. A clinician that trained for 6, 7, 8 years is not going to sit in a dark room and look at old stale videos and segment videos for hours and hours and hours. It's a waste of their talent, it's a waste of their time. You also don't want computer engineers saying this looks like a cancer to me and annotating it for you. So it's a real difficulty. And in pancreatic in particular, many of these lesions are fairly rare, so you need to find these videos, which is difficult. So what's required for annotation? Expertise to understand video, annotate software, need for feedback, correction, validation, very important, and management. So we were lucky at IHU, we already had a validated tool called Mosaic. That's an annotation software that really speeds up annotation dramatically. Took what used to take 5, 6 hours to annotate one 10-minute video of an EUS to 30 to 45 minutes to annotate it. So, and that's an open source thing, so you can look at the IHU website if you're interested in that. So 1 million images there, and 2 focuses. One is identifying where the clinician is in the anatomy of the pancreas. So head, body, tail is very relevant for the surgeon if they're going to need to go in and operate, and then lesion detection. So those are the 2 key things we focused on. So identifying solid lesions, cystic lesions. It doesn't really tell you if they're dangerous. It doesn't tell you if you need to biopsy. It just says you went by that, you missed it. You should go back and focus on that and decide clinically what to do. So this progressed on to 2022. We did the first in human clinical study. Here you can see the setup. We had an observer out there. The clinician was not allowed to see an action on the device and the information, but the external expert was. And so we could compare how they were doing and which lesions they missed and which ones the AI saw. And this is the structure of that study. Did 5 patients. This has all been published, and you can look up some of our academic results from this study. I think what was important is IHU is a translational research facility, so as I said, we had money to invest to commercialize this. So in 2023, we did a joint venture with a medical device company in Germany. In 2020, by the end of 2023, we had breakthrough device designation by the FDA as a medical device. We're currently in the FDA trial, and it's currently at MDR for CE marking as well, and we're projecting this will be an actual device on the market in first quarter of 2025. So just,
sorry, go ahead.
Just very briefly, a video of kind of what this looks like as a commercial unit. You can see a box down here. You can see the real-time projection on the screen. This would be an additional screen and not an overlay or anything like that, showing the clinician where they are in the pancreas and helping them identify lesions so they don't miss lesions. And that was the focus the FDA asked for us, was the lesion miss rate to decrease that. Current research focus is still on that same subject and is mostly around navigation, augmented reality navigation, once again to aid the practitioner, and that's going along well as well. There's many other opportunities, as you might imagine, and in conclusion, translating AI into medical solutions is hard work, but it's certainly possible. So 2020 to 2025 isn't bad in the medical device field. Validated annotation pathways is really a bottleneck and is very critical. And we feel strongly that AI tools like this can improve the overall quality of patient care, especially in kind of esoteric and difficult fields like EUS. Thank you.
Thank you.